Yeah, hello people. Uh, Welcome to the interview preparation session. Sorry for the delay. Actually, we have been faced some network issues from our side. Uh, Now, as starting the session, uh, earlier we have been seen few of the questions on Python, which means what are the libraries, how they work, how they move, and how what are the inbuilt functions in it, how to write a code for resetting a function, and all. So now let us see something which is important, more important in this. I have been came with a topic on data science and the interview preparation questions. Some of the questions regarding this data science. So if you have, as going to the first question, what do you understand by labeled training dataset? So what does it actually mean? uh, what do you understand by it? If anyone knows the answer, please ping me in the chat box. I'm been seeing the answers. We would be discuss the answer in a minute. Yeah. Now, as going to the answer for this, what do you understand by labeled training dataset? So, it is a process of identifying the raw data and adding one or more meaningful and information labels to provide context, so that a machine learning model can learn from it. So this label training datasets, it actually defines a raw data uh, by adding some more meaningful information to it, which means extends it, which gives a which provides a meaningful context to the machine learning models. Okay, this is the this is what this label training dataset is used for. As coming to the next question, what kind of machine learning algorithms would you use to walk a robot in various unknown areas? So yeah, we have come across many robotic activities and movies and all. So regarding that, uh, what algorithm do we choose to walk across a robot in various unknown areas? So if anyone knows the answer, please ping in the chat box. I would be seeing your answers, and we'll discuss the answer in a minute. Yeah, as getting to the answer of this. Huh. The best machine learning algorithm to allow a robot to walk is unknown terrain in reinforced learn, where the robot can learn from response of the terrain to optimize itself. Okay. Yeah. As coming to the next question, what kind of machine learning algorithms you can use to segment your user into multiple groups? So, what kind of algorithms do you choose among the machine learning algorithms? I'll be giving you a minute. We'll discuss it in a minute. K-means cluster. Uh, if we come across data science, you might get an idea about this K-means cluster. It is a popular unsupervised machine learning algorithm method. Uh, in layman terms, it finds all the different clusters and group them together while keeping them as small as much as possible. That means you can end up with the most possible customer segment to interpret. Okay, so if you want to choose for ML algorithms for this multiple groups, you would go with this k-means clustering. Okay. Now, as coming to the next question, can you please explain the difference between the regression and classification? Yeah, I would giving you a minute. You please ping me in the chat box. I've been seeing your answers. We'll discuss it in a minute. Yeah, let's come to this answer. Uh, Regression helps predicting a continuous quantity. Classification predicts the discrete class labels. Example weather, which means regression it helps to predict the continuous quantity without any break. Okay, whereas the classification predicts the discrete. Uh, I think you might have an idea on continuous and discrete data. So, as comparatively, regression helps to predict the continuous, whereas the classification helps to predict the discrete. Okay. As going to the next question, what is out of bag evaluation? What does it mean? If you have any idea, please ping in the chat box. We'll discuss it in a minute. Yeah, as looking into this answer of this, what is out of bag evaluation? Out of bag is also called out of bag OOB error, also called as out of bag estimate. It is a method of measuring the predict prediction error of random forest, boosted data, decision trees, and other machine learning models utilizing the bootstrap aggregations like bagging, boosting, and all. It only bootstrap aggregating only by using baggings. Okay, yeah. As going to the next question. Uh, we look at machine learning software almost all the time. What do we apply machine learning to hardware? Almost every time we would being seeing the machine learning algorithm using software, right? If in case you want to keep this machine learning algorithms all in a hardware time, so how do you use it? How do you keep it? That was my question, and I would be giving you a minute. We'll discuss the answer in a minute. Okay. Yeah. As looking into this, we have to build this machine learning algorithms in system verilog, which is a hardware development language, and then program it into fpga, which means field programmable gate array, to apply machine learning algorithms to hardware setup. So this is how we use machine learning algorithms in hardware to hardware. Okay. Now, as going to the next question, what is your strategy to handle categorical dataset? So, how do you handle this categorical dataset? This is my question. So, I'll be giving you a minute. We'll be discuss the answer in a minute. Okay? Yes, coming to this, one heart encoding. So, I think you might hear this name. So, one heart encoding is the most common correct way of dealing with not ordinary and categorical data. It consists of creating an additional feature for each group of the categorical feature and work each observation belongingly. If either the value is 1 or not the value is 0 to that group, it depends on that group. Okay. Now, as going to the next question, what do you understand by underfitting and overfitting models? So I'll be giving you a minute. We'll discuss the answer in a minute. If anyone knows the answer, please ping in the chat. Yeah, as getting into it, overfitting. Overfitting, what is it? Uh, it is of good performance on the training data and poor generation to other test data. Okay, this is how we get an idea on overfitting. As coming to the underfitting, poor performance on the training data and poor generalization at other test data. So as comparatively, these are the understandings of by underfitting and overfitting models. As jumping into the next one, what is the main difference? What is the difference between the cross validation and bootstrapping? What are the differences between them? I would be like to give you a minute. Yeah, I was looking into it. Cross validation. A cross validation, it basically splits the available data set to create multiple data sets. Okay, and bootstrapping method use the original data set to create multiple data sets after resampling it. It uses the original data set to create multiple after the process done by called resampling with replacement. Okay, bootstrapping, it is not as strong as cross validation when it is used for model values. Okay, this is the difference between them. Now as jumping to the next one, uh, what do you understand by Silhouette coefficient? So if anyone have an idea, please ping me in the chat box. I would be looking into them. If you don't have an idea, please wait for a minute. We'll discuss the answer. Okay. Yeah, as going to this Silhouette coefficient, this Silhouette value is the measure of how similar an object is to its own cluster, which means comparisons, how same or how different they are comparing to other clusters. Okay, this Silhouette range from -1 to +1, whereas high value indicates that the object is well matched to its own cluster and poorly matched to neighbor cluster. Okay, yeah. This is how we understand about Silhouette coefficient. Now, as coming to the next one, what is difference between the predictive modeling and descriptive model? If anyone has an idea, will please ping me in the chat box. I would like to see those answers. Uh, we'll discuss it in a minute. Okay. Yeah. Now, as seeing the differences between them, yeah. Descriptive analytics tells you what happened in the past. Okay, predictive data tells you what will happen in future. Okay, prescriptive analysis recommends actions you can take to affect those outcomes. Okay, yeah. This is the main difference between the predictive modeling and descriptive modeling. Okay. Now, as coming to the next one, is a high variance is good or bad? Yeah, I think everyone have attended the previous sessions. We have been discussed about all this like variances, libraries, sets, tuples, list and all. So is high variance is a good data in the data being a high variance is a good one or a bad? Please share your thoughts in the chat box. I would be seeing it, and we'll discuss the answer in a minute. Okay. Yeah, higher variance directly means that the data spread is big and the feature has a variety of data. Usually, higher variance is a feature is seen as not so good quality. Okay, we might prefer higher data, but we mostly prefer very low variance data sets. Okay, there are some data sets with high variance, I know that, but mostly we have been gone through only the low variance techniques. Okay, now as coming to the next one, uh, if your data set is suffering from high variance, how would you handle it? Yeah, till now we have discussed about uh, in the data set, if it is a high if we have a high variance, is it a good data set or a bad data set? And now I am asking you that, if the data set having a high variance, how would you handle those kind of data set? If you have an idea, please ping in the chat box. If not, please hold on for a minute, we'll discuss the answer in a minute. Okay. Yeah, as looking into it, for data sets with high variance, we could use the bagging algorithm to handle it. Okay, bagging algorithm, it splits the data into subgroups, which means it divides the data into subgroups with sampling replicated from random data. After data is split, random data is used to create rules using a training algorithm. Then we use pooling technique to combine all the predicted outcomes of the model. Okay, so the first step is we'll just split the data into subgroups, and then we used to if there is high variance, we will the first step to be noted is we have to split the data into subgroups. And the second, after splitting the data, data is created using the training algorithm. Then we have to use this polling technique to combine the predicted outcomes. Okay, these are the three steps to be followed if there is a high variance in the data set. Okay, as coming to the next one, explain learning mechanisms of linear regression. Yeah, if anyone knows about this, please ping me in the chat box. If else, I'll see you there. Yeah, now as looking into this answer, linear regression is a machine learning algorithm based on supervised learning. So we all know there are different types of learnings. There are supervised learning and unsupervised learning. Each has their own approach, which is a top to bottom approach or bottom to top approach. So this linear regression it follows this algorithm follows based on this supervised learning. So this linear regression, it performs the task to predict a dependent variable value y based on the given independent variable x, which means the value of y totally dependent on the value of x. Okay, so this regression technique finds out a linear relationship between x input and y output. So it basically finds the relationship between the both of these variables. Okay, now as coming to the next one, what is kernel trick in a svm algorithm? If anyone knows the answer, please ping in the chat box. I'll be waiting for a minute, and let's discuss the answer in a minute. Okay. Yeah. As looking into the answer, the kernel trick is a mathematical function uh, which when applied on data points, okay, and it can find the region of classifications between two different classes, not the same classes but two different classes, based on the choice of a function. Okay, uh, be it linear or radial, which purely depends upon the distribution of data. One can build a classifier. Okay, this is how the kernel trick is in SVM algorithms. Now, as jumping into the next one, list popular cross-validation techniques. What are the popular cross-validation techniques we use it? We use them. Okay. Yeah. The popular cross-validation techniques we use are k-fold, stratified k-fold, leave one out, bootstrapping, random search CV, grid search CV, and all. These are the popular cross-validation techniques which we use mostly use. Okay. There are most of them, but mostly we will prefer this. Okay, name the techniques used to find similarities in the recommendation systems. Okay, yeah, I'll be giving you a minute. Yeah, as looking into it, Pearson correlation and cosine correlations are techniques used to find similarities in recommendation systems. These are the techniques which are used to find the similarities between the recommendation systems. Okay, now as coming to the next one, what ensemble technique is used by random forest. Okay, we use some ensemble techniques to for this random forest. Right? What kind of ensemble techniques we used for this? So I'll be giving you a minute. Okay. Yeah, as coming looking into this, bagging, it is a technique used for this is a technique which we used for random forest. Random forest are a collection of trees which works on sample data from the original dataset, with the final predictions being a voted average of all the trees. Okay, so for the in this random forest, we use some ensembling techniques. So what kind of ensembling technique? Which means bagging, it is a type of ensembling technique we used for random forest. Now, as jumping into the next one, what do you understand by market based analysis? What does it actually mean? If anyone has an idea, ping me in the chat box. Okay, I'll be looking into it. Yeah, Aditya, it's bagging. It's right. Yeah. Now, as looking into the answer, the goal of actually, what do you understand this by this market-based analysis? Okay, the goal of market-based analysis is to understand the consumer behavior by identifying the relationship between the item that people buy. Okay, this is how the understanding should be between the buyer and the consumer. Okay, by consumer and the owner. Okay, yeah. As coming to the next one, what are the benefits of pruning? There are many benefits. Among them, I have been chosen some of them. Those are it reduces the overfitting techniques. It shortens the size of the tree. It reduces the complexity of the model, whereas increases the biasing. So these are the benefits of pruning. Yeah, thank you. That's it for the day. So we have been gone through some of the Python questions, okay, for 3 days, and now I have been gone through some of the important questions of data science. So let's see more of them from tomorrow. Okay. Yeah, that's it for the day, guys. Thank you and have a nice day. Bye.